Okay, this is 8.EE.8.a, 8th grade. Expressions and Equations 8, Subpart A, Video 1. I would like you to know how to convert standard form into slope-intercept form. This is kind of a precursor to the actual standard where they are going to have us graphing a system of equations. That would be 2 or more equations, and they're going to be on the same grid. And our job then will be to see if the lines intersect, and if they do intersect, we're going to talk about what happens at that particular point. Before we get into that though, this video is going to have us practicing converting one form into the other. We're going to need to be in some type of graphing form, and we're going to use slope-intercept. A few terms to know. I'd like you to copy these down and define them in your journals. Standard form versus slope-intercept form. The second one in blue here is the one that we use most often, I would say, when it comes to graphing linear equations. We should be familiar with it. We've talked about it this year a few times. And let's just see how this looks when we start converting or solving for this y variable. All right, in standard form, we have our ax plus by equaling c. If I were to put this into slope-intercept, we're looking for y equaling mx plus b, and it all really plays into where this equal sign is. So I'm going to create our famous wall here, write down the equal sign, and that creates two sides of the equation. And whenever I do this, I look and see what I want on each side of the equal sign. So I created a left side over here, and I've created a right side. Well, looking at my slope-intercept form, on the left side, all I want is a positive 1y. So right now on the left, I see a positive 5y. So I'm going to stabilize that right now. There's my equal sign. And I'm going to notice that the 2x does not belong on the left, so I'm actually going to throw it over to the right side. In other words, we're taking the term and doing its inverse operation. Well, the inverse of adding 2x is subtracting 2x, so it would be gone on the left, and then we would have 10 minus 2x on the right. I use a quicker way. I just say, if you're going to take a term and put it on the other side, you're basically changing the sign that's in front of it. So if we had a positive 2x on the left, it's going to be a negative 2x on the right. And this 10 that's on the right, I'm not moving it. I don't want to bring it to the left because all I needed over here was y values. So I'm going to keep it over on the right. I did not change its sign, so it remains positive 10. Okay, we are almost there. It says that I have 5 y's, and we don't want 5 of them. We want 1 of them, and we want it to be positive. So if we're thinking of our inverse operations, to get rid of this product, this is a multiplication right here. The opposite of multiplying by positive 5 is dividing by positive 5. And to balance that out, we would have to do that to both sides of the equation. So everybody gets divided by positive 5. All right, now we're going to simplify this. The 5's will cancel. We're left with positive 1y equaling. All right, now we have this fraction, and if we can simplify it, we will. And then make sure that you're looking at the signs too. So a negative divided by a positive is a negative. We can't simplify this fraction any further, so it remains 2/5. There's your mx. And then positive 10 divided by positive 5 is a positive 2. Okay, now we are in good graphing form. I know that I can put a dot on the y-axis at positive 2, and then I can do my slope of negative 2/5. That's that rise over run. And we're going to get into that in video 2 when we actually start graphing this. So I'm going to remind you how to do the y-intercept and the slope again. All right, second one, same idea. We have standard form and we're going to convert it. Let me start this time just by recopying the equation. All right, we have our wall. That has created a left side and a right side. I'm going to stabilize the y value on the left, and it looks like that is going to be the negative 10y. So take the sign that's in front of each term. And we are going to subtract 3x from both sides. I could show the work if you want me to. So we have a positive 3x. We're going to do the opposite of that. The opposite of adding 3x is subtracting 3x. And then we would do the same thing on the right side, subtracted by 3x. All right, so I'm kind of doing it a little differently this time to show you your inverse operations. So let's continue here. 3x minus 3x is 0x. That's exactly what I wanted to have happen. I wanted to eliminate that x value from the left. And now I have negative 10y equaling this 20 minus 3x. All right, next step. We have a negative 10 multiplied by y. I need to make that into a positive 1, y. Well, the only way to do that would be to divide each side by that same coefficient. So dividing by that number that's touching the y. And then everybody gets divided by that negative 10. Let's simplify that out. Negative divided by a negative is a positive. 10 divided by 10 is 1. So there's our positive y. And then I have 20 divided by negative 10 would be negative 2. And negative divided by negative is a positive. And if I can reduce this 3/10, I would, but I really can't reduce it, so I keep it as 3/10 x. And now let's check our form. If I'm looking for slope-intercept, which is mx plus b, I don't have my mx as my first term. You know, technically, it would be incorrect. Both of them could be a correct answer, but if I want to really get it into the slope-intercept, I'll make sure the mx goes first. So let's flip-flop those two terms, but make sure we take the sign that's in front of each. That's very important. So if I take the positive 3/10 x, it remains positive, and this negative 2 would go to the end. And I am ready to graph this equation. Final answer. All right, I think I have 2 more for you. It's just going to be practice. So, you know, if you'd like to pause the video right here and give it a try, go ahead. Okay, we're back. We have 2x plus y equaling 8. Let's create 2 sides of the equation. Write down the equal sign here. Stabilize the y value on the left. Throw that term from the left to the right. It becomes the opposite sign, which is negative 2x, and the 8 did not change signs. And looks like we're good. Positive 1y equals negative 2x plus 8. We don't really need that positive sign in the front there, so we have negative 2x plus 8. Final answer. All right, last one. All right, get that line going. Stabilize the y value. All right, we have a negative 4x on the left. Throw it over to the right, it changed signs. This time we're actually turning it into a positive 4x. The 9 doesn't change. And now we need to make that y into a 1y. And you remember, divide everything by that coefficient, which was a 3, so everybody by a 3. And simplify. So 3 divided by 3 is 1y equaling, all right, 4 divided by 3 is an improper fraction, but when we're talking about graphing lines, we're going to need a fraction anyways. We're going to need that rate of change, the rise over run. And I don't think, we can't really simplify it any further, so let's keep it at 4/3 x, and then 9 divided by 3 is a positive 3. Okay, so the idea of that video is to just teach you how to convert a standard form into slope-intercept form, and then in the next video we're going to start graphing these 2 or more equations on the same grid and talk about what happens when you do that. In your journal, I'd like you to define the given terms on page 2 of the flip chart and write a few sentences on what you learned from this video. Any questions, please write them down. Bring those questions to class and we will answer them together.